Welcome back, everybody, to Innovation Nation. I'm so excited to have Steve with us today. Steve and I met a few months ago. Actually, we met through a mutual connection. Carrie Getz, who is a big thought leader in the industry, and Steve is doing something pretty awesome when it comes to data centers and edge technologies. So, Steve, if you can please introduce yourself and share with us, who you are, what you do, and then we'll get going.
Yeah, thanks, Sarah, and I appreciate you inviting me on. It's a pleasure to be here, and Edge is a very exciting place to be right now. So, like you mentioned, my name is Steve Jacobs, and I started the company called Velocity Data Centers, and we focus on edge compute and edge data center capability.
Thank you. And if we can start there, Steve, and kind of help, let's set the stage a bit. If Edge is obviously a really great place to be. If you can help with defining Edge from your perspective, so the listeners can understand what we mean when we say Edge.
Yeah. Well, it's hard to ignore what's happening in what we might think of as the core, the cloud capability. Think of that as the center of this whole compute revolution. What we're discovering, though, is that there are plenty of circumstances where we need to be closer to where the data is created and then computed and then consumed. And so in those circumstances where we need to be closer, that's where you start thinking about things called edge compute. So when we say closer, what does that mean? It could mean from the cloud into a tier 2 city or to a tier 3 city. It could be even going from that city all the way further down into an agricultural farmlands for smart agriculture. It could also, if you look at some of the extreme edge that people are doing, it could also mean all the way down to a wearable device or a sensor package that sits on a piece of machinery or a vehicle. So edge means a lot of different things. Where we fit in that paradigm is downstream from the core, but not all the way down to the individual device or wearable or piece of sensor tech that sits on the vehicle or tractor or whatever. We sit in that middle ground, and there's lots of processing that can happen in that middle ground that that makes our particular place in the paradigm very, very interesting.
So, before we get into like velocity and like how that came about, obviously,
Mm-hmm.
story behind it, I would love if we can just quickly talk through a couple examples of what we consider maybe edge computing, edge
Mm-hmm.
technology, right? And and
Mm-hmm.
and first off, maybe it's important we talk about the benefits, right? You're talking about you mentioned that we need to be closer to the data that's being computed, right? And
Mm-hmm.
there's reasons why. So could you help us understand a little bit around what some of those benefits look like when we're utilizing edge technology versus maybe the traditional that we're used to utilizing when there's the core and everything
Mm-hmm.
kind of goes downstream from the top down. I know I try to not get too technical on these,
Right.
but if you can help kind of break that down, that'd be great.
Yeah. So when we talk about the next iteration here, which when edge compute integrates with cloud computing, what we're really talking about is when sensors, video feeds, different types of things that create data need to talk to other things that need to use that data and turn it into information. So a lot of people would describe that hyperscale and core cloud compute was really focused on humans and humans' use of technology. The edge is really more focused on machine to machine. So how does that work? What would be a good case study? A good example is in the future when we have autonomous vehicles that are driving through our cities, there's a lot of context that that vehicle needs to understand in order to safely travel through the city. The sensor package on the vehicle itself is going to be creating and consuming its own data. So you could consider that an edge application, but it also needs to talk to the city and ask the city some contextual questions as well. Is the crosswalk clear? Are there emergency services going through my area? Is there a traffic accident? There's other things that the vehicle needs to understand. So the only way it's going to understand that context is if that localized sensor array that is collecting data about the city is has the ability to talk to the vehicle that's traveling through that portion of the city. What's happening on the west side of town has nothing to do with what's happening on the east side of town. So the idea that we would try to centralize that data doesn't really make sense. What we really need to do is keep that data in its local context, but also when it is in the local context, it creates the fastest possible cycle of collecting the data, computing it, and then returning that information to the people or things that need that information. So it's a very fast processing loop, and the way that we do it faster is we put things closer.
I I am mesmerized by the way you just explained that, because it is you did such, I mean, kudos, because I think that often we hear people talk about edge computing and they just don't get it, or they just
Mhm.
don't understand in context like what it means. And I think you did a really good job at breaking it down, because also if you take it one step further, edge technology is a very generalistic term. And so
Mhm.
when you think about it, everything like the autonomous vehicle car, the autonomous self-driving cars example, what is happening on the west side isn't happening on the east side. You can break that down, that concept, into many different applications and
Mhm.
all different types of technologies that exist today, whether it's physical security or it's building automation or it's whatever it is. There's the concept of taking the smarts from the head end, where we
Mhm.
typically have it on the top of the hierarchy, to the edge, allows us to be able to create environments that are way more customized and
Mhm.
applicable to what that environment actually needs versus
Mhm.
the one size fits all concept.
Yeah, yeah, absolutely, and that touches on the whole concept of um, not all applications, not all pieces of data are the same. So the idea that we're going to basically just assume that what can happen, in the core is, is suitable for everything and everybody is just not a reasonable, situation. So edge compute really, it boils down to it's delivering compute capability where compute capability needs to reside. It's not really about big economies of scale and all of that. You build small, very purpose-built structures that put compute horsepower literally right in those very neighborhoods and right in those farmers fields and right in those places where that compute makes the most sense. And as much as 5G and as much as we can continue to build fiber and Starlink and all these other technologies, connectivity is amazing. However, it comes down to latency, network cost, and really performance of the system overall. And so all of these things, none of these things really compete with each other, frankly. A lot of people say cloud and which is going to win, cloud or edge. It's not like that. It's we all have to coexist, because when you give the creators of technology this canvas to decide where their workloads and where their data needs to be, and you can give them as many choices as possible, that's how we end up with this whole revolutionary advancement. So that's how we're going to get to autonomous vehicles. That's how we're going to get to smart farming. That's how we're going to get to a lot of these things, is giving people the flexibility to do you know everything everywhere, frankly.
It's a really good point, and I think it's a great segue now into kind of explaining what you do, Steve, and if you can give us a little bit of the backstory and the why and the mindset behind Velocity, right, and where it came
Hmm.
from and where it's going, that'd be awesome.
So it's taken a while to get to this moment when the industry has really started to understand that edge compute is a thing. I don't want to suggest that I had some kind of crystal ball, but what I can tell you is, in a previous role that I had, I started what back then we called application service provider. So I was able to deliver um, very critical line of business applications to our customer base over the internet. This was way before web services. We used a different type of technology back then, but we called it application service provider. Today, we would call it software as a service.
Mm-hmm.
The thing that really just stuck with me was that as good as we were at delivering our applications, our customers wanted us to deliver everything through that model, and we just couldn't. There were some technical limitations that meant we couldn't do it, and there were some legal, ramifications if we tried to host competitor software. Ultimately, at the end of the day, what we discovered is we could only do, as good as we were, we could only do about 65 to 70% of their environment. And we just couldn't do the rest of it. And that little idea stuck with me. So when people talk about cloud, cloud, I love it. It's great. It works really well for obviously lots and lots of people, but we all kind of knew there were applications and sets of data that were being left behind. And that's when we started thinking about, well, what would that look like? How would we build a company, and what would we do, and what would we build? So it turns out that it manifested itself into an actual product. It's a small form, purpose-built, special data center that allows people to put in workloads that they need to operate in the local space. I think one of the innovations that, among many, there's one, I think, from a business model that we did that others might struggle with, is that when you understand why people like the cloud, one of the reasons they like the cloud is because it puts their spend model into their operational budget. They can pay for things monthly. It doesn't require capital appropriation committee. It doesn't require, services contracts for generators and batteries, right? It's this heavy asset that people really didn't like when they had to own their own data center. So what we've been able to do is we've been able to flip the model over and bring that operational spend capability even right down to your own. If you wanted to do your own data center in your own parking lot, you could buy one of our edge data centers on a monthly subscription model and look out your window and see it. And it's going to give you all the control and performance and security, but you pay for it in the similar manner that you would pay for a co-location or a cloud opportunity, elsewhere. So that's one of the big changes that one of the innovations that we came up with is how do we deliver this capability at the edge, but do so, without asking everybody to do a big capital spend, because nobody wants to do capital anymore. It's all subscription based, monthly pay as you go. So that's some of the things. So back to your original question, it's a special data center. It's got all the bells and whistles of a data center that you would expect. And then, we can deliver it to, in a consumption model or an OpEx model, or we can deliver it in a capital model, whichever the customer, prefers.
Okay, that's a really good explanation. And so when we talk about like this idea of looking outside and seeing your own data center sitting right
Mm-hmm.
there, I'm sure lots of people raise concerns. So I want to kind of poke a little bit here, because I'd love to understand, it's obvious it's a turnkey unit, right? So
Mm-hmm.
it comes everything you need. I kind of like a data center as a service, you get to manage it yourself. What is it? So if we can talk like the actual structure of it, and I'd like to kind of understand like the guts of it and how you
Mm-hmm.
guys actually build it and what that looks like without giving away too much information.
Right. Yeah. So a couple of characteristics that went into the design of the structure itself was, how do we make it small? But when you go inside, how do we make it feel like and behave like a big data center? Big data centers have, lots of space, and technicians can move around, and you can maneuver within the space itself. And that's actually a fairly tricky combination of how do you handle airflow, how do you handle power, how do you do all these things in a small, and when I say small, I typically represent it as, something that would fit in the size of a basketball court. So how do you take a basketball court size data center that can deliver hundreds of kilowatts of power to the IT environment, but do so in a way that when you're inside of it, looks and feels and acts just like a very large data center. And frankly, I've had people who've come to see our showcase, they said, if you'd have put a blindfold on me and walked me in the door, I wouldn't have known that I was in something so small. I would have expected, I would have thought I was in a very large data center. So that's one of the big design things that we went with is how do we do that? And one of the very first things that we do, frankly, is we don't engineer it for people. We engineer it for equipment, which means there's no conference room, there's no glass foyer that is all fancy and a big lobby. There's no conference room, there's no restrooms, there's no drinking fountain, there's none of that extraneous human element. It runs hot in the hot spaces, it runs cold in the cold spaces. It's a very purpose-built tool shed for IT equipment, and IT equipment can operate in a wider variety of temperatures and humidities than what people find comfortable. And so that's what we engineered towards. The building itself has lots of impressive credentials in terms of its physical characteristics. It's rated against, tornadoes and hurricanes, ballistics, like literally you can shoot at it and it won't hurt anything. It's got seismic zone, fire rating. One of the key things that my information security friends often say is that, there is no operational security without physical security. So you got to start with fundamentals 101 on physical security. So there's all sorts of elements of physical security that make the building itself very hardy and robust. And then of course, on top of that, we can layer on operational security and so on. As far as internal componentry, we use a lot of the same industry vendors that you find in every other data center, big or small. We do, for redundancy, we just updated the system. We're now doing 2N power and 2N cooling. And we can do that in a price point that is well below trying to do it in any other way. And it comes back to how do we make this cool little data center so efficient and so robust, but keep the cost numbers down? And it comes back to the purpose-built nature of it. And frankly, it comes down to the pre-engineered elements, right? So think of it in terms of software. When someone buys a piece of software, the software people don't write the code every time someone buys a piece of software. They write the code once and then they duplicate it as many times as possible. So that's what we've also done, is we've flipped the model over. We don't do custom builds. We do pre-engineered builds that can deploy a certain amount of defined capacity. And we can do that very quickly because the bill of materials, the supply chain is all worked out, and it's quick, right? Edge, remember, with edge being location, it's really, I can't wait 2 years, 3 years to get workloads up and running in a particular location. I need something there in 3 months, 4 months, right? And so those are a lot of the little nuggets that we put into this thing, and it turned out that we've hit the bullseye pretty much on everything.
So like if we talk through, I mean, I don't want to undercut or I don't want to downgrade by calling it prefab, because it's really not necessarily prefab, but
yeah,
it's kind of like, it's so interesting because I feel like quite often you see end users and you see customers spending millions on millions of dollars, not even just going into the construction of it, because the construction of it is a whole nother story,
right.
but design, right? And it's so interesting how I feel like from a cost perspective, you have the ability now to eliminate so much of that up front and really get people what they need when they need it. And you don't have to wait years to get your data center deployed.
Yeah. Yeah, that's exactly right. You know, it's so some of the key things that you touched on is we are an incremental um, build model, right? So if you think of it in terms of you know, when we talk to some of our managed services and data center partners, right? We talk about you only deploy capacity into a location, into a region, when you know you have the business case to support that investment. So it's a very specific, directed investment into that region. And so you start working with a smart city. The smart city says we're putting in camera tech. The cameras are going to create a few hundred terabytes a day of data. What are we going to do with it? Well, now we just developed a business case right there that says, let's drop an edge data center so we can capture that video feed, and then plan for some capacity increase in order to allow for the rest of the stuff to catch up, right? So it always typically starts with one use case. It justifies the business investment, but it's a very incremental approach. You know, we don't go into, you know, try to be respectful with this, but we don't have the field of dreams kind of vision, right? The whole, if we build it, they will come. We don't approach our business model that way. What we do is we go work hard, we define the business case up front, and then we make those investments to move into a region. And, and for some folks, you know, that's, it's different, you know, than how they would approach the market. For us, it's the way that we can be most effective.
So what are some of like the sweet spots for you guys, like when it comes to the verticals or the types of customers you're working with right now?
So what's interesting is if you want to talk about the trifecta of where we're getting a lot of traction, it's in healthcare and manufacturing. And I say trifecta because it helps those two industries in three particular ways. If we pick on healthcare for a moment, everybody is probably aware that the data center that was built inside the hospital 15 or 20 years ago is tired. It's worn out. It needs a little help. CIOs had hoped that the cloud was the answer. And for most of their portfolio, it is, right? You can host your EHR, you can go to cloud for other systems, but ultimately you end up with a 20 or 30 cabinet payload that just can't go off property. Typically it's your PACS environment, but it's basically those last 20 or 30 cabinets that just everyone kind of has surrendered to the idea that they're going to be in that old data center forever. What we say is, let's call a timeout. Let's pick up those last 20 or 30 cabinets. Let's put them into an edge data center that's out in your parking lot. Along the way, we can flip your spend model to operational budget, which is what you want to do. And when we're done, you can go back into that 5 to 15,000 square foot data center and repurpose it for revenue.
Mm-hmm.
When you can appeal to clinical service lines, chief financial officer, CIO, and facilities with one message, you're onto something, right?
Yeah.
And when hospitals are clamoring right now to figure out every conceivable way to recover revenues that they've lost, you know, because of the craziness of this year, taking a real hard look at their service line mix and understanding, can I expand? Can I create a new service line? Where would I put it? I don't have $100 million to create a new wing, but I only need a few thousand square feet. You know, we create this pathway to revenue and clinical services that is, you know, business justified in just a matter of months, right? Manufacturing is similar, but a little bit different. Similar in the sense that the square footage within a manufacturing plant is ultra premium square footage, and IT guys, people will cower at the idea that they have to ask the plant manager for more space. I mean, that's like the worst possible conversation to have. But then at the same time, the plant manager is saying, we're putting in manufacturing 4.0. We have manufacturing simulation software. We have industrial IoT. We have video. We have barcode. We have all these things that are coming, if not already here in manufacturing. where are we going to put it? And so, what are you going to do? Pump it out to the cloud? Probably not. This is very sensitive, IP type of data. And so what do you do? And so in that scenario, it's almost the same story again, in the parking lot, paid for monthly, preserving precious floor space while giving them that local horsepower they need to collect and compute the data for their industry 4.0 or manufacturing 4.0 initiatives. So those two are just skyrocket. It's crazy, the conversations in those two spaces.
So, I mean, before we end, because I know I want to try and keep it concise, but I do want to give you an opportunity to kind of help me understand, or help the listeners also understand the future, right? Like what looking forward. And you touched on a lot of great points. We talked about edge computing. You share with us kind of the sweet spot, how we can integrate this into an existing environment today. But what do you think, I mean, from your perspective, because you're working in this every day, data centers, the data center world, I mean, IT and where we're going, obviously cloud is one of which is something that continues to evolve. But I'd love to understand from your perspective, like, what do you see the future being around the edge concept, right? And like, where could you see this going, without revealing too much of your own roadmap, right? But like, I would love to understand your perspective on what the future holds for us.
Yeah, so if you think about the near term, right, these very specific opportunities to help healthcare and manufacturing are already occurring. They're here and now. Edge compute is a little bit longer road, right? As people start defining what does it mean to be a smart city, and as the OEMs catch up with autonomous vehicles, autonomous commercial vehicles, autonomous, farm equipment, things, drones, so we are going to be, getting further and further into this, edge, but that's a little bit longer road, and we have to be patient as that develops. Along the way, I see a couple of very interesting things that we have to solve along the way, and one of them is the sustainability model. Already the Department of Energy is stressed about the number of data centers that are being created and the demands on the power grid that large data centers place. If we then complement the large hyperscalers with thousands of edge compute data centers, we now end up with a demand of power that is really, unsustainable, frankly, in the modern era. So microgrid technologies, we're working with some folks to integrate microgrid capabilities, things like fuel cell technology, solar technologies, second run batteries, things of that nature, micro turbines, because it actually is self-serving in two ways when it comes to microgrid. Number one is, we want to be good to the planet and good to the community and help the sustainability story. But on the other hand, if we're literally putting an edge data center out into a commercial farmer's, cornfield, we're not going to have utility power out there. We're not going to have the ability to just tap into the grid. We're going to have to figure out how we can power our edge data centers with our own creation, our own generation. So microgrids and sustainability kind of go hand in hand. And I'll just leave you with a small little interesting thing to think about is how does, and I'm not going to answer this, I'm just going to put it out there. Think about smart city, autonomy, data, and the electrification of the vehicle fleet. How do those things all kind of come together? We've got some very interesting proof of concept beta projects in the works right now that connects the dots on all of that and does so in a way that
I already have an idea.
Yeah. Well, I think you and I may have touched on it before, but it's when you combine all of those things together, you end up with a very different perspective on how the future of edge and what edge looks like going forward. So it's very fascinating time. Like I said, edge is a great place to be, and we're having a lot of fun.
Well, thank you so much, Steve. I know there's like so much more I'm sure we could have touched on, obviously, like when it comes to IT and security and how do we know someone's not going to break into the center. But obviously you guys have thought that through and it's been well planned and designed to get you to have the success you've had today. So I'm excited because I think there's going to be a huge future with this. And as you know, like I work at a company where we create an edge device, right? And it's really cool technology and how we're really taking, like with what you're doing and what I think our industry is starting to do in general with edge technology, we're really bringing the smarts truly to the edge. And people, obviously there's always going to be that concern of how do I know it's safe and protected, but there's a reason why we encrypt things, and there's a reason why we build things to be tamper proof, and right. And we think ahead in that sense. But it's really cool because also you brought up microgrid, you brought up fuel cell concepts. I think that would be an interesting, case study one day to see you guys do that, where you really can have this like self-sustained net zero like data center. Really think ahead. I mean, that would be pretty awesome to see one day and help our planet. That's for sure.
Yeah.
So thank you, Steve. Are there any like last thoughts or ideas that you'd like to share, or kind of touch points on the future of where you guys are going? Also, like if you could share before we end how folks can get in touch with you, that would be great as well.
Yeah. No, I appreciate the time with you today, Sarah. It's been great. And, I think that, the intersection of what you're doing and what we're doing is clear and obvious. And there's I think a lot of when you think about an edge computing data center being a lights out, unstaffed facility, having the capability of what you guys bring to the table is absolutely paramount to making sure that the right people are there, and they're there with permission, and we know about that, right? There's a lot to that, and so no, I appreciate you taking the time to have me on, and then reaching us is pretty simple, velocitydatacenters.com. You can also email me directly at steve.jacobs, Jacobs, at velocitydatacenters.com. And, and obviously they can always reach out to you and have trouble the other way.
Right? LinkedIn.
Oh yeah. Yep. We're on LinkedIn, and yep. So all the classic ways.
Thank you, Steve, so much. And I'm sure you'll have some outreach, and we're excited to get this posted, and we'll talk to you soon. Thank you.
Yep. Thanks, Sarah. Thanks so much.